Hello, today's video is going to be on angle pairs and their relationships to each other. So we're going to start off by talking about some vocabulary words. The first word is adjacent. When we say that two angles are adjacent, I'm saying that they are touching each other. And they're not touching just by the vertex. One of their angle sides are actually touching each other. So they are sharing a side. So angle 1 and angle 2, those would be adjacent angles because they are sharing one side of their angle. It is not adjacent if they are here and they're only touching by a vertex. That's not good. What we want is for the entire side of the angle to be touching to each other. A linear pair is a specific set of adjacent angles. A linear pair is a set of adjacent angles that form a straight line. So here we go, we've got a linear pair. In that linear pair, they are forming a straight line, and a straight line is going to equal 180 degrees. So two adjacent angles equaling a straight line, which is 180. Supplementary is sometimes a linear pair. A supplementary has less requirements than a linear pair. A linear pair, the angles must be adjacent and they must equal 180. A supplementary is any two angles that equal 180. So I could have 140 degrees here and then a 40-degree angle over here. Two completely separate angles, but these two angles are supplementary because they add to 180. That's the only thing that you need for supplementary. They have to add to 180. They can be non-adjacent or they could be adjacent. If they are adjacent, that means that they're also a linear pair. So a linear pair combines being adjacent and being supplementary together. Vertical angles are angles that are across from each other. And when you have vertical angles, they are forming the letter X. So angles 1 and 2 are vertical angles. They are across from each other in an X. Sometimes this gets confusing and you think that if it forms a K, angles 1 and 2, you think that those are vertical angles, and you can see it this direction. If you flip the K here, you think that those are vertical. That is not true. That is no good. In order for it to be vertical angles, you need only 2 lines to form those vertical angles. To form the K, you need 3. You need the straight line and then each branch of the K. So when you think about vertical lines, think you only need 2 lines. They're across from each other and it forms the letter X, not the letter K. If it's not an X, it's not vertical lines. Complementary is 2 angles that add up to 90. So you can have adjacent angles. That means that you have a right angle, which is 90 degrees. You can have 2 adjacent angles that touch and add to 90. Or you can have 2 non-adjacent. And non-adjacent just means that they're not sharing a side. And they add up to 90 degrees. So adjacent, they're touching. Non-adjacent, they're not touching. Supplementary, they add up to 180. Complementary, they add up to 90. All right, let's go ahead and use these relationships. When we look at number 1, we have a lot of different relationships, a lot of different equations that we can set up. What you want to do is you want to look at it and you want to go with your instincts. What relationship do you see first? The relationship you see first may not be the best. You keep going with all possibilities. So maybe as I look through here, the first thing I see is that these two are forming a straight line. If they form a straight line, that's a linear pair. And what we know about a linear pair is that they add up to equal 180. So 3y plus 20 plus x plus 53 is equal to 180. As I look at that equation, I've got a problem. I've got an x and I've got a y. If I have 2 variables, then I have to have a system of equations, 2 variables, 2 equations. When I look at that, I don't have 2 equations, I only have 1, so I can't solve that just yet. So maybe like, oh, well, there's also another linear pair here. These two angles also form a straight line. So I could write another equation with a linear pair. So x plus 53 plus 5y is equal to 180. Now I have two equations, both with x's and y's. I could rearrange these pieces, set up a system, and solve, but that sounds like a lot of work right now. I'm going to look at a different relationship just to see maybe we can get something a little bit easier. We also have this vertical angle relationship. Vertical angles are congruent. They have the exact same measure. So when I see these two vertical angles across from each other, anytime I have vertical angles, I can set them equal. So 3y plus 20 has the same measure as 5y. We move the smaller of our variables to keep our variable positive, divide by 2, and we get that y equals 10. Now that I have y is 10, I can go back to either one of these other equations that I had set up, and I can plug y in. I'm just going to go to the second one because it's there and I've got room below it. And I can plug that in and I can solve for x. So x plus 53 plus 5 times 10. X plus 53, 5 times 10 is 50. We simplify, add our like terms together. 53 and 50 is 103. We move the 103 by subtracting, always that opposite operation. And we get that x is going to be equal to 77. All right, so in that problem, we had a lot going on. We had multiple variables, we had multiple relationships. Look at everything in the problem and work through it until you find something a little bit easier. Again, we could have done it this way, a lot more work. When we look at number 2, very important thing I look at in the diagram is I see this right angle. This means that these are forming a right angle, which is 90 degrees. We're going to use our angle addition here and apply the angle addition to this complementary relationship. It takes this angle and this angle together to equal the whole right angle. So we do 3x plus 2x plus 10 is equal to 90. We combine our like terms. We subtract our 10. 5x is going to be equal to 80. And we find that x equals 16, using that complementary relationship and that angle addition together to solve for x. All right, one last problem. This is a ratio problem. So the ratio of two supplementary angles. And as you're reading a problem, it's really important that you're paying attention to each of the vocab words. As soon as I see supplementary, I'm going to think to myself that it needs to add to 180. That's an important relationship that's going to come into play. The second thing I see is that I want it to be in a ratio of 4 to 8. So 4 equal pieces to 8 equal pieces. If I have 4 on one side, 8 on the other, that's going to give me 12 equal pieces total. Just like when we did slope of a line and we broke our slope into different pieces, equal pieces, same thing here. But instead of dividing a segment into equal ratios, we're going to set angles into ratios. So we have a supplementary angle. So what I know about that supplementary angle is that it's going to make a straight line at a 180. So two angles forming a straight line in a ratio of 4 to 8. So there's going to be 4 equal pieces on this side, 8 equal pieces on that side. If I were to break that down, that means 1, 2, 3, 1, 2, 3, 4 angles here. And let's see if we can divide this, making it look. 1, 2, 3, 4, 5, 6, 7, 8. So when I break this up, I'm breaking my angle into 12 congruent angles. And I want to find the place where it's going to break that into 4 equal pieces on this side and 8 pieces on that side. To set up our equation to solve, having the 4 to 8, all we have to do is add an x. We want to find the measure of that unknown angle. So 4x plus 8x is going to be equal to that linear pair, that supplementary relationship of 180, which gives us 12x, which is 180. That's where this 12 equal pieces is going to come in. This diagram helps clarify where it's coming from, but I know from the ratio how many equal pieces I want to divide that ratio, that supplementary angles, into. So I want 12 equal pieces of an unknown angle to equal 180. What is the measure of that angle? So we divide by 12, and we find that that angle is 15 degrees. I've got 15 congruent angles, or sorry, 12 congruent angles of 15 degrees each. I want to find it so that it's divided, 4 on this side, 8 on that side. So I've got 4 angles of 15, giving me 60 degrees, and I have 8 angles of 15 on this side, giving me 120. So when I want to find the measure of my two angles, it's a 60-degree angle and a 120-degree angle. Okay, and that was the last problem for today's video. We are all done.